This is a pretty simple circuit, and we need to find the voltage drop V0 across the 4 kilo ohms resistance. So what we can see here is there are two parallel paths, one containing 5 kilo ohms resistance, another one is also 4 plus 1 plus 4 5 kilo ohms resistance. So these 2 milliamps current will be half of it will go this way, half of it will go that way. So V0 is of course 4 kilo ohms times 1 milliamps, that's 4 volts. Now the second part of the question is, if a voltmeter, this is a voltmeter of internal resistance of 6 kilo ohms is connected across the 4 kilo ohms resistance to measure the voltage drop, what would be the measured value? Ideally a voltmeter's internal resistance will be infinite, but this has a resistance which is 6 kilo ohms, and that is comparable to this one. So we need to calculate what will be the resistance. So in effect what happens, these two resistances come in parallel, as we can see. So the equivalent value of that will be 4 times 6 divided by 4 plus 6, so that is 2.4 kilo ohms. So the circuit will now become, with the voltmeter resistance, this will be 5 kilo ohms here, 1 and 2.4. So 1 kilo ohms there, 5 kilo ohms there, and this is the combination resistance. The circuit's 4 kilo ohms in parallel with the voltmeter 6 kilo ohms. So this will be the resistance in effect. So what will be the voltage drop, voltage measured by the voltmeter? That's what we want to find now. So this is 2 milliamps. So the measured voltage, let's say Vm, that will be now 5 plus 2 plus 2.1, these two are in series, so 3.4 times 5, this will be the current, and this times 2.4 will be the measured voltage. So this is 3.4, so this is the current, 1.19 times 2.4, 1.19 times 2.4, that's 2.857. So much less than the actual voltage drop, which is 4 volts, and that is happening because the voltmeter has a comparable resistance, comparable with the resistance that's voltage across which voltage drop it's trying to measure. So this here, this part is current, because I have applied current divider rule, basically two parallel paths. So this is the total current divided by sum of the two parallel paths resistance. This is 1 plus 2.4, that's 3.4, and times the other resistance, which is 5 kilo ohms. That gives me the current through this branch, and then multiplied by the resistance gives me the voltage in volts, because this current is in milliamps and this is in kilo ohms. So that's the voltage drop, which is much less, and this is happening because the voltmeter resistance is 6, which is very much comparable. If it were higher, the measured voltage would be closer to the actual voltage drop. So which we will do, I will do another problem which will show that that thing. So